NEC 410.73 addresses fluorescent ballasts used for egress lighting that are normally off. It's important to understand its specific wording. The code doesn't explicitly prohibit thermal protection. Instead, it stipulates that such ballasts shall not have automatic thermal protection. This nuance is key. To further clarify, UL Standard 935, which covers luminaires, directly addresses this point. Part Roman 7, Section 43.3 of UL 935 requires that compact fluorescent lamp luminaires intended for emergency lighting and that are normally off shall not have automatic thermal protection. Therefore, when carefully examined, the NEC and UL requirements are not actually in conflict. They both aim to ensure safety in emergency lighting situations, but approach it with specific considerations for automatic thermal protection. Now let's discuss the practical availability of compact fluorescent lamp downlights without automatic thermal protection. It's true that such fixtures aren't commonly found readily available on the market. The reason for this is that manufacturers typically prioritize compliance with UL requirements, which often include thermal protection as a standard safety feature. However, this doesn't mean it's impossible to obtain such fixtures. Some manufacturers might be willing to provide custom solutions. This often depends on the specific application and the project requirements. If your project necessitates compact fluorescent lamp downlights without automatic thermal protection for emergency lighting that is normally off, there are several recommended steps to consider. Firstly, consult with the local authority having jurisdiction. It's crucial to ensure that your proposed design complies with all local code requirements. The HJ has the final say on what is permissible in your jurisdiction. Secondly, contact lighting manufacturers directly. Inquire about custom solutions or modified products that can meet your specific requirements. Be prepared to explain your needs clearly and provide detailed specifications. Thirdly, be prepared to provide documentation and justification to the authority having jurisdiction. Clearly explain the need for departure from standard UL requirements. Provide supporting evidence or reasoning to demonstrate the safety and suitability of your proposed solution. Beyond these steps, there are additional important considerations for emergency lighting systems. Ensure that the entire emergency lighting system is designed and installed in strict accordance with all applicable codes and standards. This includes not only NEC 410.73 but also the entirety of NEC 410, as well as Article 700, which provides comprehensive guidelines for emergency systems. Take into account the potential risks and develop appropriate mitigation strategies for using emergency lighting fixtures without thermal protection. Conduct thorough risk assessments to identify potential hazards and implement measures to minimize them. Establish a schedule for regular testing and inspection of the emergency lighting system. This regular maintenance helps to ensure its proper operation over time. Consistent testing and inspection are crucial for maintaining the reliability of the emergency lighting system. Now, let's delve deeper into the technical aspects of thermal protection in fluorescent ballasts and its implications for emergency lighting. Thermal protection is designed to prevent ballasts from overheating, which can lead to fire hazards or premature failure. When a ballast exceeds a certain temperature threshold, the thermal protection device automatically shuts off the ballast, interrupting the flow of electricity and preventing further temperature increase. In normal operating conditions, thermal protection is a valuable safety feature. However, in emergency lighting applications, especially where the lights are normally off, automatic thermal protection can present a problem. If the ballast overheats during an emergency situation and the thermal protection device shuts it off, the emergency lighting will fail, defeating the purpose of having it in the first place. This is why NEC 410.73 and UL 935 specify that ballasts in such applications should not have automatic thermal protection. The goal is to ensure that the emergency lights remain illuminated as long as possible during an emergency, even if the ballast is operating at a higher than normal temperature. It's important to distinguish between automatic and manual thermal protection. Automatic thermal protection refers to a device that automatically shuts off the ballast when a certain temperature is reached. Manual thermal protection, on the other hand, requires manual intervention to reset the ballast after it has overheated. NEC 410.73 and UL 935 are specifically concerned with automatic thermal protection, as this type of protection can cause the emergency lights to fail without warning. When considering alternative solutions, it's crucial to carefully evaluate the risks and benefits of each approach. For example, one option might be to use ballasts with a higher temperature rating. These ballasts are designed to operate at higher temperatures without overheating, reducing the risk of thermal shutdown. Another option might be to improve the ventilation around the fixtures to help dissipate heat and keep the ballast cooler. It's also important to consider the overall design of the emergency lighting system. The system should be designed to minimize the load on the ballasts and ensure that they are operating within their specified limits. This can be achieved by using energy-efficient lamps and ballasts, and by distributing the lighting load evenly across multiple fixtures. Regular maintenance and testing are essential for ensuring the continued reliability of the emergency lighting system. The system should be tested regularly to verify that all of the lights are working properly and that the ballasts are operating within their specified limits. Any problems that are identified should be addressed promptly to prevent them from escalating into more serious issues. In addition to the technical considerations, it's also important to be aware of the legal and regulatory requirements for emergency lighting. Emergency lighting is typically required in commercial buildings and other public spaces to provide illumination during power outages and other emergencies. The specific requirements for emergency lighting vary depending on the location and the type of building. It's essential to consult with a local authority having jurisdiction to ensure that your emergency lighting system complies with all applicable codes and regulations. This may involve submitting plans for review and obtaining permits before installing the system. In some cases, it may also be necessary to have the system inspected and certified by a qualified electrical inspector. Compliance with emergency lighting codes and regulations is not only a legal requirement, but also a moral obligation. Emergency lighting can save lives and prevent injuries during emergencies. By ensuring that your emergency lighting system is properly designed, installed, and maintained, you can help to protect the safety of building occupants and visitors. Now, let's consider some specific scenarios and examples to illustrate the application of NEC 410.73 and UL 935. Imagine a conference room in an office building that is used for presentations. The room is equipped with compact fluorescent lamp downlights that are normally off. However, the downlights are designed to turn on automatically in the event of a power outage, providing emergency lighting for the room. In this scenario, the downlights are considered emergency lighting that is normally off, and therefore NEC 410.73 and UL 935 would apply. The ballasts in the downlights should not have automatic thermal protection. Now, consider a different scenario. A retail store has fluorescent strip lights that are used for general illumination. These lights are normally on during business hours. However, in the event of a power outage, a generator automatically starts up and powers a separate set of emergency lights. In this scenario, the fluorescent strip lights are not considered emergency lighting, even though they may provide some illumination during the power outage. Therefore, NEC 410.73 and UL 935 would not apply to the ballasts in these lights. It's important to note that the distinction between emergency lighting and general illumination is crucial in determining whether or not NEC 410.73 and UL 935 apply. Emergency lighting is specifically designed to provide illumination during emergencies, while general illumination is intended for normal use. When designing an emergency lighting system, it's important to carefully consider the specific needs of the application and the requirements of the applicable codes and regulations. This includes selecting appropriate fixtures and ballasts, designing the system layout, and ensuring that the system is properly installed and maintained. The authority having jurisdiction can provide valuable guidance and assistance in navigating the complex requirements for emergency lighting. They can also help to ensure that the system is safe and effective. Remember that the primary goal of emergency lighting is to provide a safe and reliable source of illumination during emergencies. By carefully considering all of the relevant factors, you can help to ensure that your emergency lighting system meets this goal and protects the safety of building occupants and visitors. To summarize, understanding the nuances of NEC 410.73 effort in relation to UL 935 is crucial for ensuring code-compliant and safe emergency lighting systems. While off-the-shelf compact fluorescent lamp downlights without automatic thermal protection may be challenging to find, exploring custom solutions and consulting with the authority having jurisdiction are viable paths to achieve the desired outcome. Always prioritize safety and compliance with all applicable codes and standards when designing and implementing emergency lighting systems. Regular testing and maintenance are essential to guarantee their proper functioning when they are needed most. By taking these steps, you can ensure that your emergency lighting system provides reliable illumination and enhances the safety of building occupants during critical situations. Finally, remember that technology and codes evolve. Staying updated on the latest revisions and interpretations of the NEC and UL standards is crucial for maintaining safe and compliant electrical installations.